Hey everyone, Mr. Daler is here. Today we are going to learn about total internal reflection, another spectacular phenomenon happening with the light. So let's remember we have learned about the refraction of light. Make sure you have a clear understanding of what is refraction. Now let's continue with another phenomenon here. So what is total internal reflection? Why do we study here? Is there any use of it? Yes, of course, it has a wonderful application and use in real life. So now what did we say? When investigating and studying refraction, you might have noticed that not all the light is refracted. Some is reflected back from the surface. As you can see in the picture given here, some of the light is reflected back. So check the figure given here. As the light emerges from this side of the block, it is coming down there here, emerges upper side from this straight part. A part of it is being reflected, so we call it as internal reflection, right? When a ray of light strikes the inner surface of a material and some part of it is reflected back. Now the ray enters the curved part of the block without bending. Pay attention, because it is coming along the radius, it is coming along the normal line here for this surface, all right? But on the straight part it will be refracted, but some part of it is reflected. Okay, this reflected part obeys the law of reflection, where angle of incidence must be equal to angle of reflection here. Now let's move on to continue. This rays reflected back inside the material can be very useful. So what happens next depends on the angle of the incidence. At what angle the ray of light is coming. Here 4 cases are given. Let's start analyzing all of them quickly. First one is when the ray of light is coming, part of it is reflected, most part of it is emerging to the air and refracted. Part B, let's increase the angle of incidence. Now our main focus is what happens if we increase the angle of incidence according to the normal line here. In this case, again, similar thing happening, only the difference is angle of refraction, as you can see, is greater. It is moving away from the normal, and that's the main focus here. What happens next? If you increase further and further, it will reach a case when the light is just on the boundary between the air and the glass, and some part of it is reflected. Then what happens if you increase further the angle of incidence? All the light will be reflected, and that's what we call as total internal reflection. Now next I'm gonna put a very short video. It's about 1.5 minutes. Watch it carefully. It experiments the total internal reflection with the same semicircular glass block here we have. He will increase the angle of incidence each time, and you will clearly see that the light will be totally reflected back inside without passing to the air. Let's move on now. So as you have watched in the video, the total internal reflection happens after some certain angle. Let's summarize it here clearly. We have a source of light. First condition is when the light comes with the 0 degrees to the normal. What happens in this case? The light will just pass to the air without bending 0 degrees. It will continue. Now if it comes with some angle to the normal and it passes to the air from water, it will refract, right? As you can see, it is refracting. And why the angle is bigger here? Because when it passes from medium to air, it will refract further away from the normal all the time. So as we increase, analyze the case 3, 4 here. As we increase the angle of incidence, every time angle of refraction is also increasing and increasing. At some point, at some angle, it will reach 90 degrees, right? So it will be just at the boundary between the air and the water here. So that angle, we call it, it's a special angle, so we call it critical angle, all right? After that angle, what happens? If you send further more light at the greater angles, they will be all just reflected back. In this case, the water will act as a plane mirror, so it will reflect back all the light here. So take a note, total internal reflection only happens when the light goes from some medium into the air, not the reverse. In the reverse, it is not possible. Okay, so let's continue. So to summarize, total internal reflection occurs inside the material, not in the air to material. Okay, if the light is coming with some angle which is equal or greater than the critical angle, and we call it, we show it as C, critical angle C. All right. So total internal critical angle is a keyword here. Total internal reflection is another keyword here. Make sure you are taking very good notes here. So what is TIR? When a ray of light strikes the inner surface of a material at the boundary between material and air, and 100% of the light reflects back inside. All right. As you can see in the pictures, when the light goes with the angle equal to the critical, the light will be just on the boundary. Increase it a little more, then you will have total internal reflection as shown in second picture here. In that case, there will be no refraction at all. Now next, take notes of some values for the critical angles. So for the water, it is 49, glass 42, diamond for 25 degrees. Did you see the trend here? As it goes from water to diamond, the angle getting smaller and smaller. So it means the greater the index is for the materials, or the more optical dense the material is, the critical angle will be smaller and smaller. That's why the diamond reflecting a lot inside it, and it will look sparkly jewel. Now to continue, check your understanding by answering these questions, question 17 to 19. Now next part is about to investigate the relation between the critical angle and the refractive index. So as we said before, the greater the refractive index of the material, the smaller the critical angle would be. So to see how critical angle and refractive index are related, now let's use an equation to drive the key equation to come up with the final equation to calculate the critical angle for the materials. Now let's start with the same old equation we have studied before for the refraction. What was it? N equals sine I over sine R, sine of angle of incidence over sine of angle of refraction. Now take that particular case for the semicircular glass block or any other materials, doesn't matter, where we have a ray coming and refracting, being on the just boundary case, so that angle would be critical, right? But for simplicity, we will reverse the case. We will say the light is coming on the boundary and going along the radius. Just change the arrow because this phenomenon is reversible. So what happens next? Put the values. In this case, the angle of incidence, as you see, is 90 degrees, right? The light coming along the boundary, so it means it has 90 degrees with the normal. So sine I would be sine 90 over R, refraction angle would be now critical angle, so sine C. So, and we know that sine 90 is just 1, right? And then put the values back. N would be equal to 1 over sine C. Rewrite it and you get the key equation here. Critical angle would be 1 over n, or sine of critical angle would be 1 over n, and this is our key equation, next key equation for this chapter. Now, to reinforce our understanding, please check the worked example. It is on your book. Find a critical angle C for the diamond. Assume that refractive index for the diamond is 2.4. So to check and understand the solution, please check 244 of your book. Alright, let's continue now. Next, we have the uses of total internal reflection in real life applications. First one is the optical fibers. It revolutionized the telecommunication and signal processing technology, brought a revolution both in speed and capacity of the telecommunication networks around the world. Our digital signals are passed along the fine glass fibers. Yes, the optical fibers are made up of glass, and they are thin, long, flexible wires, and they carry the signal, the message from one point to another along long distances. So they are used everywhere in the internet, telephoning, and cable TV. What happens inside the fiber? Light travels along by total internal reflection. So it will bounce each time it strikes the cable, because it comes with an angle greater than critical angle when you draw normal at that point, so that it will bounce back, and every time it will bounce back, it will be confined inside the fiber. And so that is the magic of the total internal reflection, and it's widely used, and we are highly benefited from total internal reflection and optical fiber cables. Now, next use of optical fibers is in medicine. As you can see in the picture, doctor analyzing the internal organs inside of the body of a patient with a special device called endoscope. So what happens? One bundle of fibers carries light down into the body, another bundle carries image back to the user, to the screen. And in this second image, you can see it is a picture from inside internal organ of someone here. Or similarly, the third use can be the light used in sensory play to soothe or stimulate children with sensory processing issues. So using optical fibers will mean that children can play freely with light with no risk of electrocution or burning. Now I'm gonna put another small short video. It's again around 1.5 or 2 minutes long, so make sure you watch it again. And this is an experiment about total internal reflection done by Cambridge. It will give some insights and some measurement as well.
A ray box can be used to investigate the properties of light. The refractive index of a material is linked to the critical angle. This is best investigated using a semicircular block of the same material. The angle of incidence is increased until total internal reflection occurs. An optical pin is used to mark the path of the ray of light. A protractor is used to determine the critical angle. The critical angle and refractive index are linked by an equation. N equals 1 over sine C. The greater the refractive index of a material, the smaller the critical angle. This experiment has demonstrated the refraction of light. The refractive index and critical angle of the material have been determined.
Alright, we came to the end of today's lesson. I hope you enjoyed. It was all clear. If anything is not clear, please make sure you come and ask. Lastly, now scaffold your learning, your understanding about total internal reflection by solving and answering this question, questions 20, 21, 22, 23. It will be for the 2 lessons. All the best. Bye bye.